right. So this is 2.7, number 8, and it says a certain bacteria population is known to double every 15 minutes. It doubles every 15 minutes. An experiment is being conducted in a microbiology lab. Suppose there are initially 7 bacteria in the Petri dish. Make a table and a graph and an equation that will predict the number of bacteria in T hours. Okay, so when they say this 15 minutes business, that is a huge clue. Okay, I'll explain what that means in a second. So an experiment is being, sorry, suppose there are initially 7 bacteria. So whenever they say initially, you will always go with, oh, that's 0. So at 0, I'm sorry?
So 0's initially?
Yeah, that's like your starting point. So then here's 0. So how many bacteria are there at time 0 or hour 0?
Mm-hmm.
So how many? Anybody? You can say.
Well, none? No, wait.
No, read right here.
Oh, 7.
Yes, very good. So there's 7. Now it says, listen to this. It says a certain bacteria is known to double every 15 minutes. So I know this says in hours. So in my brain, I'm going to say this is in minutes. So this is 15 minutes out here. So that's 0.25 of an hour. You guys all agree with that? So if it doubles every 15 minutes, how many is here? How many bacteria are here?
14.
Exactly. Now, why is it 14? Because it said
doubles.
Yeah.
It doubles.
Yes. So this phrase right here is super important. So if we forget this phrase, the doubling every 15 minutes, then you can't fill out this table. This table will be like, I don't understand what you're talking about. So because I love tables so much, I'm going to continue my little table. I need to make this a tad smaller so I can fit everything. So then 30 minutes, this is 0.5 of an hour. And then, okay, now it's doubling. Okay, so some people are like, then you just add 7 to it? No, you're doubling
14 by 14 and then so on and so on.
Yes, so that would be 28 and then 56. And I'm going to reserve the last little guy for n hours. Okay, so this is not, some people say, but Ms. Johnson, but it's a double, so shouldn't you just add 7 to it like the original? No, they didn't say that. They said it doubles. So think about, I don't know, this is like if you sent out a tweet and every single one of your people sent it to twice as many, like sent it to 2 more people, right? So that's what that looks like. Okay, so then we need to figure out this. And so the way I like to write these out is not by using these numbers. I like to actually write it out like this. So how did we get that 14? What did we do to get our 14?
We doubled it with its own number.
Good. In math land, when we say double,
we use to the power of 2.
No, not to the power of 2.
Wait, no, wait. Wait, what was it again? I forgot.
So how did you did 14 plus, I mean, you did 7 plus 7. Yeah. So someone in the chat says, hey, Ms. Johnson, it's times 2. So here, instead of writing 14, I'm going to write 7 times 2, right? Okay. And then instead of writing 28, I'm going to write 7 times 2 times 2. And some people are like, wait, that doesn't make sense. Let's try. 7 times 2 is 14. 14 times 2, yeah, that's 28. And again, 7 times 2 times 2 times 2. So I'm building this equation because then I'm going to ask you the questions. What stays the same and what changes based on our number of hours here, right? So let me do, I want to do that, sorry. Okay. So if you look here, instead of writing it like this, I'm going to classically write this like equals 7 times 2 equals 7 times 2 squared, because I don't want to like have to write times 2 times 2 times 2. I'm going to write them as exponents, right? And again, 7 times 2 cubed, right? Okay, so that is my table, and I'm already getting ready for my, oh, it says T hours. Shoot, I should make this a T. So there's T right there. Okay, so there's my table. And then it says make a graph that will predict the number of bacteria in T hours. Okay, so now this brings me to having to write an equation in T hours. Now T, if you look here, these are not whole numbers. So these are sets of 15 minutes. Can you guys think about it like that? These are sets of 15 minutes, right? These are sets of 15 minutes. So how many 15 minutes sets do I have here? I have one, and then that means I have 1, 2. How many sets of 15 minutes do I have here? I have 2. That's why I have 2 2s here. 3 with 3 and 4. It's how many sets of 15 is going to be my predictor, which is something that we haven't done in our class, but that's okay. So let's go back to this. What's staying the same here?
Well, the amount of times you multiply it.
Good.
7.
Good. So what's staying, I'm going to put a 1 here because I do need my 1. I'm going to put T down here. So if I put a 1 here and I just continued this on, right? I'm not even going to write the answer here. I know that it's 7 times 2 times 2 times 2 equals 7 times 2 to the 4th. Okay. So I'm trying to link this back, but that's okay. Oh, you're not catching up to me. Give me a second. Okay, so then now I need to figure out a model. So do you see how the 7s keep appearing here over and over and over again? So that means that my 7 is going to stay here in my model. 7 and then 7. All of these 7s are going to stay. And that makes sense because that was that's our initial conditions. That's what they call it, initial conditions. You'll see him over and over again. In reality, if you think back to our 2 equations, this equation is our principal. This is how many we started with, right?
Mm-hmm.
And then we have these 2s everywhere. So my big thing is I need to figure out, right? I need to figure out what exponent goes right here. That's my big thing. I need to figure out what exponent goes right here. So the way I do this is if I plug in 1 here, I should get out this number here. When I plug in 1, I should get out this number, but I already know it, right? Right? How many 2s are there for 1?
Like 4.
Good. There's going to be 4 of these. So, but that, how do I get this to make sense? Okay. But because this is 1, how many times did you already double it? 1, 2, 3, 4. You doubled it 4 times, which is why it's 4 here, right?
Mm-hmm.
So how do I get this in? Oh, okay. So the way we're going to figure this out is now I want to figure it out for T. What if it's for T? How many am I going to have to put in here for T? So no matter what, I want to be able to plug it in and then get out the answer. So one of the things that I can possibly do is pick one of these numbers that I already know, and I'm going to plug it in here to try to get my 14 out here. Does that make sense? But the easier case is going to be me doing it here. So I'm going to use one of these points to find out what exponent needs to go here in order for me to do that. Does that make sense? I'm looking for my base. That makes sense?
I mean, okay, never mind. I got lost.
I know, it's okay. I am also, the weird part about this one is that it's increments of your 15 minutes, which is really, really weird. So I kind of want to take you back to, I kind of want to take you back to the idea of when you first learned this. And when you first learned this, you understood that if I plug in 1 to here into my function, I should get out this number. And so the thing that I'm thinking about in my brain is these are sets of 4. So if I look at this and I extend my table all the way out, I have 1, and then 4 more sets would be 2, 4 more sets would be 3. So even though this is 4 sets of 2 for 1 hour, my brain wants to say this number right here is going to be 4 t. And the reason why this is going to be 4t is because it took 4 doublings, 1, 2, 3, 4, to get to get to my first hour. So that's my prediction. I don't know if it's right. So I'm gonna plug it in to check my answers. Does that make sense? This is just my prediction. And some of you are like, okay, well, where would you get that, Miss Johnson? I'll show you. Okay, so let's see. So let me use my little, I'll use this. So I think my answer looks like this. It's 7 times 2 to the, and like this, 4 times t. That's what my, what's wrong with this? Oh, t is not, sorry. Uh-oh, hold on a second. Yeah, okay. So that gives me this equation. And so now I want to check to make sure that I have all the numbers that I already plugged in right here. So the very first number I'm going to plug in is I'm going to plug in the number 0.25. And when I plug in 0.25, I really want it to say 14. If it doesn't say 14, then I did it wrong. It does, right? And then when I plug in 0.5, I really want it to say 28. It does. So Ms. Johnson, wait, where'd you get the 4 from? The 4 came from here because this right here gave me doubling every time, and it was 1/4 of an hour, right? This was 1/4 of an hour. So when I got to 1, I had 4 of them, which normally, if you guys remember, this number indicated how many there were here, but now it's 4 times that. So that's why this is 4 times that. Does that make sense? That's confusing. Okay, another way that you can possibly do this is go like this. You can say, hey, Ms. Johnson, I don't know about this whole stuff, but when I plug in 1, I get out 112. So then you would have said something like, okay, fine, let's go 7 times 2 to the something equals to 112. And then I would make you solve that. So can we solve this really quick? What would you do first in order to solve this? So we would side map this, right? So you're looking for subtraction or addition, right? So is there any subtraction or addition on this side? I'm going to make this my x.
No.
Yeah, there's none. So I divide by 7. Oh, sorry. And then, so then I would check for multiplication or division, and there is. So this says times 7. So I'm going to divide by 7 on each side, right? So 2 to the x equals to, oh my gosh, 7. So this is 16. My guess is this is 16. Right? Right. And then I would take log of both sides. And then I would get log base 2 of both sides. And then notice here, I'd get x is equal to 4. So that's where that 4 comes from, which is correct. That's exactly what I got. So this base here, this 16, some people will actually use this as their base here as well. But again, the reason why I got 4t here is because for each hour, I got 4 doublings. And t, if you look at t is in hours. So I really needed to count how many doublings did I get in 1 hour. I got 4 of them because it's 15 minutes. Does that make sense?
Everything past wherever 4t came from made absolutely no sense to me.
Past 4t? Okay,
Yeah.
this is just solving. Don't worry about solving for right now.
Oh, okay.
Okay. So then here, this part here, right here. This is the graph of it because we already got it, right? Let me turn off these guys. This is your graph. Where's this red guy come? Oh, he's up there. This is your graph, so you can graph that here. Let's see, write an equation. We wrote an equation, and actually there's many equations, right? So this says, and see if this makes sense. 7 times t to the 4t. This is your equation. If you look in the answer book, it looks like this, 7 times 16 to the t. Does that 16 look familiar?
Yeah.
Yeah, right. So Ms. Johnson, how are these two exactly the same? They are. These two are exactly the same. And it just depends on what makes more sense for you to write.
So it's
And
just a format.
huh?
So it's just like a format.
So it's almost like saying, like writing a paper, right? Like when you write an essay and you're trying to convince me, I don't know, persuasive essay on why pizza is better than hamburgers. The way I write my essay and the way you write your essay is going to be very different, but both of us could be correct, right? And we can even have opposing opinions if you really want to go for it. So this one is there. And then it says, between what times to the nearest quarter of an hour will the number of bacteria exceed 10,000? All right, how would I do this one? Ashley and Emily, how would I do this one? What would I do? I'd actually bring up the graph again, right? And what number would I graph? What number am I going to graph right here? So at what hour will the bacteria exceed 10,000? So what I'm going to do is I'm going to graph y equals 10,000, right? You're like, Ms. Johnson, it didn't do anything. And I say, yeah, it did. It's just way off my window. So I got to go to 10,000. Oh, there he is. Okay, so let's go to 10,000. This is funny. Okay, so I'm going to click on this and I'm looking for where they intersect. That's not it. There it is. It's right there. Ah, they're so close together. So let me change my settings. X is negative 1 to 100. That's better. All right, so I just needed them to be separated from the x-axis or the y-axis. So I click on this and I get that. What does this mean? What does 2.62 mean in our context? So thinking about that, what does that mean according to this question? Yeah, right. So 10,000 is how much bacteria I have. 2.62 is the hour at which what does it say? Exceed. At what hour do I exceed it? Okay, so then this is a rounding thing, right? They're asking for an hour. Oh no, they said a quarter of an hour. So what's the quarter of an hour that exceeds it? So they want to know, is this 2.62 closer to which quarter? What would you say? So at 2.5, technically no, right? Because at 2.5, I don't know. This is before 2.6, right? See how at 2.6, it's less than 10,000? You don't want to go that way. You want to go the other way. So not at 2.5, but at 2.75, right? So at 2.75 up here, see how you're definitely past 10,000? If you chose 2.5, this is, I don't know, maybe down here. I don't know, past here. Do you see this number? It's before 10,000. It's less than 10,000. That makes sense? All right. Okay. So I'm going to stop this.